Thank you, Illusions, for letting us know that the recording has started. This event will be recorded. However, for attendees, you will not have any audio or video, but feel free to post any questions you may have in the chat. But that's just to let you know that although we are recording the actual session so that we can share it with some other people on campus and some sponsors later, you yourself will not be recorded at all. So welcome, I'm Rebecca Travis. I am the Student Competition Center Governing Board Chair, as well as a member of Georgia Tech Off-Road. I'm really excited that you could join us today. We'll be hearing from all of our teams after we talk a little bit about the Student Competition Center itself. So without further ado, I'm going to turn it over to my counterpart, Nick Slakanen, to go ahead and get us started.
Wonderful. Hey guys, my name is Nick. I'm the Vice Chair of the Student Competition Center Governing Board. First thing I'm going to start off is just kind of giving you a brief overview of what our space actually entails. So we are a space that houses 7 competition teams with around 700 students, and we've been around for an experienced 20 plus years. So our ultimate vision is we're trying to support and encourage supercurricular experiential learning opportunities through student competition center teams, with socially conscious project-based teams and many other things included with that. Our vision is much aligned with the Institute of Georgia Technology, and essentially we are trying to provide the best opportunities for students to learn and have that experiential environment so that way they can bring that to the real world. So where is our space located? It's we're around the northwest part of campus on 575 14th Street. We're about a 15,000 square foot facility, around 1 mile off campus, and we have 24/7 student access, which makes us a really sought after spot for many of our students that are looking to use that knowledge that they have in the classroom and bring it to the real world. So much of what is happening in the SCC is with our common machining area, much of what we call the CMA. And that includes many different things such as our 3-axis CNC mills, our water jets, and many other things such as lathes. And so this allows our students and members the ability to manufacture much of what they design and to be able to test and analyze whether or not those designs are actually going to work under stress and other circumstances.
So we do have a bit of a tour video, however, we have not gotten the audio to work. So we're going to go ahead. All right, a little bit more about our members. The Student Competition Center is open to all years and majors of students. Currently, we represent about 18 majors. 81.5% of those are from the College of Engineering, so 81.5% of our students, of about 400 members that had taken our survey this past spring. However, as Nick mentioned before, typically we have between 500 and 700 students as part of our, or between all of our teams. We have opportunities in disciplines across all teams and all majors. So although we are a very engineering focused style of team, each team operates like a mini business. So looking at finances, looking at business programs, looking at the team brand, merchandise, all sorts of design. So any major will be able to find some place on one of the teams for something major specific. However, if a mechanical engineering major wants to try out some circuits or computing, that's fine too. We encourage students to try to be as multidisciplinary as possible on our teams so that they can experience what it's like both for their major going into the workforce and into any projects that may involve something beyond their major. Currently, we have about 30% of our body is first years, followed by about 24% third years and 22% second years. We are also open to graduate students, so about 8.7% of our student body are graduate students. However, a student may join the Student Competition Center at any point, whether that be first year, second year, third, fourth, fifth, even into graduate student or their graduate studies. It's really open, and all teams are willing to take students no matter what year they stand. Currently, our gender breakdown is about 80% male and about 18% female. There are current efforts in place for that to be a bit more representative of the Georgia Tech demographic breakdown, and we're working with the Georgia Tech Women in Engineering and Georgia Tech Society of Women Engineers, as well as some of the other Georgia Tech colleges like the College of Business, College of Computing, to increase our diversity of student body to be more reflective of our full Georgia Tech student body. Our teams, which we'll get to meet a little bit later, we have 7 of them, 6 of which are automotive, and 1 is a robotics organization. We have rec racing, Georgia Tech off-road, high-tech racing, solar racing, GTMS, so GT Motorsports, Eco Car Mobility Challenge, and RoboJackets. So a lot of different and unique capabilities are on these teams and based on what their challenges are, but we'll hear from them in just a little bit. However, all of these teams are challenged to really push the limits of the engineering design in their respective competition field, whether it be focusing on electronics or the mechanical portion. Some even have design and finance portions of their competition. We encourage students to practice the full engineering design cycle in order to make those sound engineering decisions. So the theory that is learned in the classroom, we want to make sure that it is applied formally through all of our different projects to make sure that when a student leaves the competition center, they understand why all the decisions were made on the vehicle, the robot, whatever project that they were. We also take pride in fabricating as many parts as possible through our common machining area, or CMA, which you can see located in the picture to the bottom right. We also utilize the Georgia Tech Invention Studio as well as the Montgomery Machining Mall. So giving students the ability to both design, fabricate, analyze, validate those parts up until its kind of final piece on the car or the vehicle. And as I mentioned, these teams are not only focused on just the design and the operations, but also looking at business, looking at community outreach. For instance, partnering with First Robotics to help out with high school and middle school competitions, as well as looking at recruitment. The 500 to 700 students that we provide opportunities to, we need to be able to reach out to them and show them the opportunities that we have. There's also a large amount of leadership and communication. Each team is responsible for their own leadership sub-team structure. However, starting with a first-year student, there's always opportunities to either be leading projects, whether that be just leading a small design, a part design, up until lead engineer, team lead, and looking at even leading higher level projects with the Student Competition Center Governing Board that will benefit the entire space. Also, we're a very large community, almost like smaller family units, where we have new member training, looking at safety and space management, and even some different socials to get to know one another and be able to work across all the teams. The Student Competition Center is a very large kind of open area. So being able to speak to each of the teams and become friends is something that's very valuable. And here's a bit more of a breakdown of how we also work with cross-team collaboration through the Student Competition Center Governing Board. There's 4 officers and then representatives of each team, as well as any team member who would like to be a part of these more upper level projects. Something that we started this year were committees. So we have 6 committees now, ranging from outreach to finances and facilities, with some of their major projects listed below. The main purpose of these committees is to have a bit more focus on running a certain portion of the Student Competition Center. All of our teams, as well as the SCC, are primarily student-led. So we, as first year through graduate students, get to help make decisions that will benefit our space and our teams. So something like recruitment with the outreach committee, working on a collaborative pipeline between all the teams, or working on hazmat protocol and how we're going to maintain that. So there's leadership at all of these levels and the ability to gain a industry or a knowledge to go into industry for all of our students. This year, we were very largely impacted by COVID-19. There's only so much work you can do virtually as far as design, testing, and validation goes. However, a big thank you goes out to everyone who helped us get back up and running in person. We were under very strict occupancy limits, but this did not deter us from being able to go into our space safely with social distancing measures in place to be able to work on all of our different projects. In fact, big shout out goes to RoboJackets, who developed a very efficient in-house people counter tracking system. So we had a good understanding and control of who was in the space at every time, because our facility is open 24/7 and we wanted to keep it that way. And teams were very helpful with kind of self-policing of cleaning and supplies management, and daily scheduling and communication. So it really took an army to make sure that we were able to be back up and running as much as possible. And the teams did not let it deter them from being able to produce very good products for their competition. Another few highlights of things that were kind of higher level this year with the Student Competition Center. We mentioned the committee structure that started, as well as our collaborative recruiting pipeline. Traditionally, teams would simply recruit individually. And this year we came together to create some events for prospective members, so that students not only learned about one team, but all of the teams, so they could make a better informed decision about which team they might like to try out. We also have developed an internal wiki structure for knowledge capture, so we're able to better hand down the information to new leadership. We're also moving towards a more tool master and trainer model for the common machining area, so taking way more ownership on the students themselves training each other and training new members, as well as more ownership on the tool maintenance. And then we are also increasing our efforts towards diversity and inclusion, which is one of our biggest goals. And looking towards the next fiscal year, a couple highlights are there's a common electronics area under development, as well as collaborative resin booths for composites work and other work. Thank you so much to our sponsors who have made that possible. And then also working towards increasing our racial, gender, and major diversity by networking with other organizations on campus. And now I'd like to introduce Dr. Cunifer, who's our current faculty advisor. Dr. Cunifer, if you'd like to go ahead.
Good afternoon, folks. Thank you for joining us all here. I'd like to make some brief comments before I speak to the implications of the slide that's in front of you now. What the SCC and its teams have been able to accomplish has been the product of very extraordinary professional coordination and maturity and responsibility amongst the student members, and taking responsibility for executing collaboratively and effectively across the multiple functions within the SCC. Recall Becca said that we're up to 700 members. We're as large as some of the undergraduate programs on campuses. And yet these teams are able to work in an effective manner to the betterment of the experience for all the teams. And even this presentation here today is a product of those students pulling together around an idea and executing on their own. And it's that level of experience, if you will, that makes these students so attractive to our sponsors as future employees, and which make them so successful in the workplace. And it's been, quite frankly, the product of a long game that we've been working toward to get the teams to this level. And I'm very gratified to see what we've been able to accomplish during these times of adversity, because it really demonstrates that the students are able to do everything I'd ever hoped for them to be able to do collectively and collaboratively. And now for the implications of this slide. I will be retiring September 1st of this year. Dr. Rhett Mayer has agreed to take over my responsibilities within the Student Competition Center and off-road and motorsports. Those are the two teams that I directly advise. Rhett brings a wealth of industrial experience and hands-on design practice, very similar to myself in that regard. So I'm very pleased that he has agreed to step into my role. He's also got visibility through the executive suite of the Institute, which, as I have found in the long game I've played, is very important for the recognition and support of the competition center. Some of the recent initiatives that Becca mentioned have been a consequence of that support. The resin booth coming in is due to support coming from the provost office. We've recently been receiving a significant support from the College of Engineering to upgrade our common machining resources and basic common operational resources as well. The common electronics area is being funded in part through one of our sponsors, Deere. And it's this diversity of support coming into the SEC is significantly improving the quality of the experience we're able to deliver to them. And I'm looking forward to assisting Rhett in the knowledge transfer of 30-odd years of advising these teams in the competition center. And looking forward to great success in the future. Becca?
Thanks, Dr. C. And it's going to be a fun summer, and we're very sad to see you go, Dr. C. But go and retire. You've been threatening it for a long time now, and we're looking forward to having Dr. Mayer come on. And we would really like to thank all of our generous sponsors of this space. Without you, some of our growth and increased capabilities really wouldn't be possible. So you make it possible for all of our students to be able to gain these experiences through whatever team that they're on or through the full Student Competition Center. So without further ado, we're going to go ahead and introduce our teams and have each of them speak. There will be a bit of time for questions at the end of each team's presentation, and you are more than welcome to use the chat feature in BlueJeans to ask those questions throughout. We'll try to answer as many as possible if there are any. And then at the very end of the presentation, we will have one more bigger kind of question time if anyone has any last lingering questions. So with that, I'm going to turn it over. Rec Racing, if you'd like to go ahead.
Hello, I'm Derek Nixon. I'm the current lead engineer of Rec Racing, and I'm also joined by Jerry Chu, who is our current secretary. Go ahead to the next slide. Yeah, so who are we? We're one of the Student Competition Center teams, and what we focus on is creating race cars from production vehicles to compete in a budget racing competition. So it's put on by Grassroots Motorsports magazine every year in October. And the premise is very simple. You have to show up with a car based off of some sort of production vehicle defined by production frame rails or a production unibody starting with your design. And then you have $2,000 to go and build up a car from there. So we use the various resources available to us in the Student Competition Center, as well as design and engineering expertise to come together and try and create the best car that we can. So we'll go and pull engines from junkyards, buy junked cars, and use some of the tools in our common machining area to create custom suspension components and different custom components to interface all those together to create the wackiest, best performing vehicle that we can for the least amount of money. So what have we been up to in the last year? So last year in 2020, we took our previous car, which was a 1986 BMW E28, to the Grassroots Motorsports Challenge, where we placed first overall. So with that car, we did a full engine swap with a custom turbocharger setup, and we engineered completely new suspension for the front and the rear, converted it to a more modern BMW suspension in the front with custom control arms with new geometry, and completely engineered a solid axle 3-bar linkage system for the rear to help, especially in the drag racing portion of that competition. And everything worked out really well. That was the second time that we'd had that car out to competition. and it performed exactly how we wanted it to, and we were very happy about that. So we came home, and currently since then we've been working on our next car, which is an Acura TL swapped Chevy S10 pickup truck, so a small mini truck from the early 2000s, and on that one, we're taking that completely down to the frame rails, and we're completely designing custom suspension on all four corners, including push and pull rod, coiled setups for the front and the rear, and completely custom pickup points and control arms and everything. So essentially the only thing original on the car will be the body work and the frame rails. Everything else will have been custom designed by us and validated using different suspension design software, as well as some CFD to get a better aero setup on the car, so we're not just pushing a big brick of a pickup truck through the air. So thank you. That's Rec Racing. Thank you guys for listening. I wanted to thank some of our recent sponsors as well, and open it up if anybody had any questions about our team.
So if you have any questions, please feel free to go ahead and put them into the chat. All right.
Oh, there we go. Do we use a new car every year? So typically we run our cars on either a 2 or a 3 year rotation. Really, it's kind of dictated by the design process for that car itself and the performance of the car at the competition. So, if we take a car and it wins in its second year, we'll move on and start building a new car. But some of our more complicated builds often will come back in 3 iterations, but 3 is the most that we've ever done. So once we, completely meet all of our design goals and the car has won in the competition, and it's time to start on a new platform that we can then, once we've run out of engineering to do on that platform, then we'll move on to a new platform to open up more room for design and for different experiences.
A question from the Q&A, Derek. How many people are involved in the project usually?
So we have between 50 to 70 active members every year in the club, depending on the semester. So we'll typically split that up and have some sub-teams, usually consisting of about 5 students to design different components and focus on different aspects like tuning the engine or, maybe machining a very specific part. But yeah, usually about 40 to 50 working on the car every year.
All right, we're going to go ahead and move on to solar racing if you'd like to take the floor.
Hello, everyone. Can you hear me?
Yes, we can.
Awesome. My name's Noah Dorfman. I'm the president of GT Solar Racing. Our club designs, manufactures, and then races completely solar or completely electric solar-powered vehicles. So we're quite a large team, and I'm going to try and go through the different aspects of our team and what each team has been up to this year. Yeah, so for the operations side of the organization, we'll start out with outreach. So we actually had over the fall, we had a record 51 recruits during the fall semester. Pretty surprising during COVID, but we're lucky to have all those members on the team. We actually usually run about like 70 to 90 members, depending on how recruitment goes. And on the next slide there's some more statistics about our recruitment cycle. So we have people coming from other SEC teams to Solar. We have quite a bit of first years as well. Basically 2/3 of the team is always first years, and then we have some people that move on to stay with the team, and that's like 1/3 of the team. We also have a research VIP section for Georgia Tech Solar Racing. So some of our students are also involved with that, and that's some extracurricular on top of the extracurricular to get with solar racing. And we also have majors from all over the place. And then with the strategy sub-team, what we've been working on this semester is taking our strategy suite that we usually use for our one-day track races and refactoring that software to be useful for our multi-day races. And while doing that, we've come up with some type of genetic algorithm that actually takes a bunch of different possibilities for strategy in the race, different speeds that we should travel at different points, and gets all those different strategies to converge and give us the best possible strategy that we can use to race. And then our business team just wants to say thank you to all of our sponsors. We had some new sponsors this year. We've gotten a generous donation from Haas, and we're also working towards a sponsorship with Altair, and they're going to be helping us get a high-powered computer to run different simulations on for our aero team. And then moving on, I'm going to pass it off to Samantha Lang, our junior vehicle lead, to talk about SR3.
All right, good afternoon, everyone. My name is Samantha Lang. I'm a 5th year at Georgia Tech, and I am the SR3 or junior vehicle lead. Our primary focus with this vehicle, which was first rolled out in 2019, has been continuous improvement to prepare it for the multi-day race coming up this summer, the American Solar Challenge. So our first significant overhaul during this continuous improvement period has been redesign of our space frame. In 2019, at our race Formula Sun Grand Prix, our car endured a rollover event during scrutineering. There were no injuries, and the frame was not visibly damaged. However, we decided it was in our best interest to reevaluate the frame and ensure that it was passing all of our test cases again. During this period, we decided to modify the frame further by adding more members in places which would further solidify our rollover cases and pass them by both our set of regulations and by professional engineering validation. And here I would like to give a thank you to Alpha, Dr. David Smith, for getting us significant advice during this period. On the next slide is our second overhaul, our new aero body. So during the rollovers, understandably, this aero body endured some damage, and additionally, the manufacturing process was not up to par. It was a rush process and did not hold up in the autoclave on the first rev. So we decided in order to improve this, we reevaluated the manufacturing process itself and took much longer to fabricate this new aero body. By taking it slow and steady, we were able to have the easiest pull of any carbon fiber body in GTSR history. Our surface was far smoother and better suited for our high efficiency purposes. And in the process, we also decided that our industrial design sub-team would give a new design in our vinyl wrap on the air body. So thank you to Delta Tech Ops for use of their autoclave in order to make this process work smoothly. Finally, on the next slide, we have our new solar array. During the process of rebuilding our aero body, we decided it was best to take new steps in improving our solar power, and we selected new solar cells with much higher efficiency. At peak point, we expect to draw 15% more power than we initially did. And in order to choose these, we went through a series of design studies to select our efficiencies and maximum power point tracker configurations, as well as cell zoning, to make sure that we were maximizing our energy draws. So all in all, this car, despite surviving a rollover event and finishing 9th place on its first rev, we thought that was significant. We now expect it to perform much better this time around, and we look forward to a double race this summer, which we hope to finish both of. And now I will hand it over to our mechanical lead, Brian Leong, as well as our electrical lead, Ben Terry, to discuss development of our next generation vehicle.
All right. Hello, I am Brian Leong. I'm a second-year mechanical engineering major here, serving as mechanical lead on the team. So for MOB, a lot of the development, the MOB is actually in the early stages of development. And on the next slide, we can see that most of the focus has been on vehicle engineering and down selecting. So largely high-level analyses of how to build the car. So this essentially broke down to two main tasks. So first of all was the research and development of the operational envelope. And so this means looking at data we have regarding the driving conditions, as well as regulations and other factors, to basically boil all that information down into braking, thermal, and crosswind requirements for the car. Also, we ran some sensitivity studies that would allow us to quantitatively optimize the trade-offs of the different subsystems of the car. So this means solar array area versus, the drag of the aero body versus the car's mass, and et cetera. And all of this allowed us to basically run through several thousand different vehicle configurations at the end of the day to ensure that we had a car that was quantitatively, according to our analysis, the best car to build moving forward. So on the next slide, a large part of this down selection is focused on the aero body development. So basically, we started off by soliciting ideas from the entire team of how we can potentially make this aero body, just to test various different concepts. We also had some inspiration from our industrial design team. And from there, we basically explored the entire trade space. So we did some optimizations of many different aero body archetypes. And we also experimented with the smaller details, such as the tunnel shapes, tail shapes, and other smaller details. And all of this required us to build on our existing knowledge of how to run CFD and CAD using surface modeling. And we also ran some studies on some smaller details that were more design agnostic, such as the door mechanisms and the feasibility of passive solar array cooling. And all of this is providing information for us to begin doing more detailed design and getting ready for manufacturing. And so I think on the next slide, I will hand off to Ben for the more electrical elements of the car.
Thanks, Brian. Hi, I'm Ben, a fourth year EE and GTSR's electrical lead. So our solar and MVP subteam has been hard at work designing the much larger solar array for our next generation vehicle. It presents a lot of new challenges, much larger area, different geometries. So we've been designing and validating a suite of modeling tools that we can use to very quickly iterate between the solar team and the aero body team, like Brian said, to quickly converge on what's most aerodynamic, but also generates the most power. And also work around other new features for the solar array, like, where's the room for a door to hinge, and that impacts how can we wire up the array, a whole host of issues there. So we've been pretty happy with the solution results we got, and an advantage too of having a car that's driving today is we can do these simulations and then validate do they actually match what we get out of our current car and get a higher level of confidence out of that. And if you can go to the next slide, another huge change for our next generation car. It's a much bigger car for more passengers, so we need, and also has a much different way of charging. So we need a much different battery pack design. So this battery sub-team has been hard at work at, again, building up some in-house tools to do simulation of mainly focus on thermal efficiency. How can we do a compact battery pack, get the heat out so it's very compact and then efficient, we're not wasting power. And also using, like Brian mentioned, the geometry of the cars, we're exploring those solution space there. Some of those mean that we have, instead of like a nice rectangle battery pack, which is easy to design, what if we need to split the battery pack in two? That presents a whole bunch of challenges, and the batteries team has been hard at work at making sure that we can make a reasonable design there.
All right, yeah, thank you, Ben, and Brian and Samantha for that. If y'all have any questions, there's quite a lot to go through there, so we're quite a big team.
We can probably take 1 to 2 questions if anyone wants to put one in the chat or the Q&A. All right, Noah, a question for you guys. Who drives the actual solar car?
Yeah, so we actually have students that are on the team drive the car. We train drivers with our race operations team all the time, or as much as possible. So we have, going into the race this summer, we have about 4 individuals who will be driving the car during the race. And then Caleb asks, how many competitions do we go to? We go to the Formula Sun Grand Prix, which is a track style event raced on Formula One tracks. And then we also go to the American Solar Challenge, which is a trail style race where we actually drive from like point A to point B over like a course of days, all with just charging on the sun. Pretty cool.
Noah, where does the track go this year?
So we're actually going on the Santa Fe Trail in the American Solar Challenge. So we'll be going from, I believe it's Independence, Missouri, all the way like through Santa Fe, New Mexico. So pretty cool.
All right, we're going to go ahead and move on to EcoCar if you guys want to take it away.
Yeah, can everyone hear me?
Yes, we can.
Cool. Hi, everyone. I'm Brianna Thornton. I'm the project manager of the Georgia Tech EcoCar Mobility Challenge team. I'm joined here today with Ishan Nico, our engineering manager as well. And today I'll be going over just what we're about and what we accomplished this year. So what is EcoCar? It's a part of the automotive competition known as an Advanced Vehicles Technologies Competition Series. And these competitions focus on things such as alternative fuels, energy sources, hybrid and electric powertrains, and driver assistance systems. During this cycle, there's been about 11 participants spanning across North America. We're one of those 11 participants. And go to the next slide. So a little bit more about our team structure. We currently have 3 faculty advisors, and throughout the course of year 3, that being this academic year, we've had about 50 undergraduate and graduate participants on the team. These students span across many majors across Georgia Tech, as well as one student from Georgia State University. And we're really proud to have such a diverse team. So the competition goals for EcoCar Mobility Challenge is to start off with a 2019 Chevrolet Blazer, convert that stock vehicle to a hybrid powertrain by designing and integrating that powertrain system into the vehicle. We also plan to develop a SAE Level 2 automation with our cab features, and I'll talk about those a little bit later. And we hope to achieve about 99% ready functionality of all of our vehicle systems. So to achieve those goals, we've decided to go forward with the P0, P4 HEV architecture. So the start of this architecture includes our GM Power Cube with the LCV engine and our 9-speed transmission. We have a 10-gallon aluminum fuel tank, a HEV4 battery pack, and we have the P0 and the P4 system. The P0 system being on the front axle. It encompasses the Denso motor as well as the Reinhardt inverter. And our P4 system on the rear axle encompasses a Magna E-Rad motor and the Magna dual inverter. As far as our cabs component to achieve those automation features that we want, we have the Intel tank being the overall cab controller. We have the Bosch radars that, as well as the mobile 6i6 camera that provides process detection data. We also have the Coda wireless radio, and that sums it up for our CAS components. So what was the goals and what did we accomplish this year? Well, we completely and reliably integrated all of those vehicle components that I mentioned earlier. We were able to have a fully functional vehicle propulsion system with basic energy management strategy implemented. And we're also working on updating our cab controller with basic functionality and fault mitigation. We are still currently running in the competition. The competition is not over this year. We still have a bit more testing to go up until the end of May. And then in June will be the award ceremony. So hopefully we will place really well during that time. As far as EcoCar's impact on its members, it provides a unique opportunity for industry-level automotive experience. Our students are able to get into the process of creating a consumer-ready vehicle and then following along with GM's own vehicle development process, so they're getting that real-world experience that's really unique to this opportunity. It provides employment opportunities for our students. A lot of times they often get internships or even full-time positions through the sponsors that help us achieve our goals of the competition. So overall, it's a very valuable opportunity for hands-on experience, and the unique aspect of it is so multidisciplinary and is spanning over a course of 4 years. So you get to work on the design phase, the integration phase, the testing phase, and the refinement phase. All of that is really important for real-world vehicle development. And with that, I want to thank our various sponsors who provide the tools and equipment necessary for us to even achieve all of the goals that we've been able to so far. So thank you so much. We really appreciate it. And now I'll open the floor to any questions.
I'll throw in a quick question. What do you mean by year 3?
Oh, sorry. So the EcoCar Mobility Challenge spans over 4 years. We're currently in the 3rd year of that competition, that being the 2020-2021 academic year. So this year was primarily focused on integrating the components as well as testing those components to make sure they're fully operating and communicating well with each other.
Awesome. And if anyone else has any questions, you can feel free to put them in the Q&A or the chat. All right. Thank you, EcoCar. So we're going to go ahead and move on to high-tech racing. The floor is yours.
All right. Hello. Can everybody hear me?
Yes, we can. Go ahead.
Okay, great. So my name is David Knight. I'm the president of High Tech Racing. Joining me to present are the chief engineer, Leo Positaniv, and the treasurer, Arvind Srinivasan. So High Tech Racing is Georgia Tech's Formula SAE electric racing team. So we design and build a fully custom electric race car each year and compete against other schools in the Formula SAE competition. So we were founded in 2013. We're actually the youngest SEC team. And in the time since we've been founded, we've grown significantly in size and distinction. We now have 80 members, and we received first place in our last two competitions at Formula Hybrid in 2018 and 2019, and we expect to do very well in our upcoming competition in FSAE Nevada, the 2021 competition. So our team has many different goals. We clearly have our vehicle goals, which lie in the design, development, our performance and placement, how well we manufacture our vehicle, and the attention to detail that we have when developing our vehicle. We also have team goals. So this year we really tried to focus on building a healthy team culture, retaining members, and focusing on knowledge transfer. So training the new members that come in so that they're prepared to take the team even further in future years. And then as well as this, we have our individual goals where each person comes to the team looking to get something out of it through engineering knowledge, they're developing their engineering skills, internship placements and career growth. So all the companies on the right here are recent companies which have been directly recruiting from High Tech Racing. And I'll hand it over to Leo, who will give you an overview of our vehicle.
So this year we've had quite a few very exciting updates to our vehicle. This year being the first year we've developed an aerodynamic package, and you can actually see in the picture on the right. It's fully manufactured and mounted on the vehicle. We've been testing it for the past couple of weeks. We also, David mentioned earlier that we're going to FSA Nevada, which is very different conditions compared to the competition in New Hampshire that we used to go to. So we really focused on modeling and understanding the thermal components of our vehicle, such as the battery pack. So we redesigned the battery segment to improve the cooling and also shave a lot of weight so that the addition of the aero package wouldn't hurt our performance. And you can see in the picture on the right, it's our new fully manufactured battery segment, which contains 18 lithium polymer cells, and we have 4 of those in the accumulator, totaling a voltage of 300 volts. It's also our first year when we manufactured a carbon bodywork, again, to save some weight. It was saved 7 pounds. It also focused a lot on testing this year, since testing the vehicle is one of the most important components of this competition and allows us to gain a lot of performance by tuning the car and training our drivers. And we already completed over 150 kilometers of testing, and we plan to test a little bit more before we go to the competition in about a month. So the performance of our current vehicle, H205, its curb weight is 378 pounds. It's only 10 pounds heavier than our previous vehicle, H204. However, it has a full aero kit, and it has a higher performing battery pack. Its 0 to 60 acceleration is in about 3.5 seconds. So it's a fairly quick car. And we've measured sustained lateral accelerations of 1.9 G thanks to our optimized suspension to maximize mechanical grip, plus our aero package. The overall power of our motor is about 100 horsepower, and it produces about 710 newton meters of torque at the wheels, which is about 160 newton meters at the output of the motor shaft. Our battery pack is 4.7 kilowatt hours, 300 volt battery pack, and the power to weight ratio of 0.25 horsepower per pound. And I'm handing this over to Arvind to talk about our team training.
So at High Tech Racing, we take new member training and community engagement extremely seriously. So normally, before COVID, we hold a series of hands-on workshops and training sessions throughout the fall so we can get our new members up to speed. However, now because of COVID, we had to adapt. So we created a fully virtual training program this year with 26 training recordings spread over the semester that had 25 hours of training material. And this covered everything from overall details on like how our car works, how our team is structured, to very specifics like circuit board design. And we got feedback from our members that these trainings not only help them become more involved, but also succeed. In addition, we took shop access and we trained new members how to operate equipment such as the CNC mills and lathe mentioned previously as part of the CMA. And then we also worked on doing community outreach. So we held community workshops, including what you can see on the right, how to build an electric race car, where we talk to new members and the general public on like our team and what we do. And these info sessions and the tabling help us to like advertise as well. And we do social media outreach. Good. So building a race car is no small feat. It takes a lot of money, and we thank our generous sponsors who help us get all the way there. So specifically SGA, through them, we get yearly budgets and semesterly bills, but also we have sponsors who give us both monetary support as well as in-kind parts donations that we especially are thankful for because they help us build a race car every year. In fact, next slide. We have over 50 sponsors and partners, and that list grows every year. For example, one of our major sponsors, Delta Tech Ops, helped us with composites manufacturing, and we worked with engineers at their facilities to learn new manufacturing methods, use their equipment, such as the autoclave you can see on the top right, and gain new experience to build a better race car. Companies like Milwaukee, General Motors have held workshops and recruiting events. And of course, we held virtual design reviews working with a company called Second Order Effects out of California that helped us go over design to just possible improvements in ways that we couldn't get feedback from actual industry members. And finally, we send regular newsletters from our teams to these sponsors, help maintain connections and keep our contacts going.
All right.
Does anyone have any questions?
Feel free to put them in the chat or the Q&A. All right, if there's no questions, we're going to go ahead and turn it over to GT Off-Road Waseek. You want to go ahead?
Sure. I'll go ahead and introduce myself. Welcome to our Off-Road 2021 End of Year Review. My name is Waseek Kabir. I am the president and team lead of GT Off-Road. Also with me is going to be Rebecca here as well, representing GT Off-Road. And just, going to talk a little bit about what we've been up to, what the progress we made this year, and some exciting new things, especially with our competition placing. So, Becca, I'll let you take it away.
All right, who are we? Georgia Tech Off-Road designs, manufactures, tests, and validates a single-seater off-road vehicle, as you can see pictured to the right, for the annual Baja SAE competitions. Typically, G-Tour is going to go to at least one, if not two, competitions. This year, we will be going to two, just competing in Arizona and going to Louisville, Kentucky in about a week and a half. We compete against hundreds of universities at the competition in both static and dynamic events. Static being things like a design presentation and a business presentation where it's almost like a Shark Tank style event. And then dynamic events, including a 4-hour-long endurance competition or endurance race, as well as maneuverability. Basically, the competition is designed to break your car. So Georgia Tech Off-Road really has to focus on the durability of our vehicle. Currently, we have over 45 students across 11 different majors and 4 of the Georgia Tech colleges. And GT Off-Road gives real-world experiences for students both in engineering and business, so a very well-rounded set of team experiences.
Going on to what we've been up to this past year, especially as everyone kind of knows, it's been very different than the usual year for us, especially with COVID and the new protocols in place of that. One of the new things is that we have new subsystems on GT Off-Road, the development of our electrical team and also a vehicle dynamics team. So our new electrical sub-team, they're responsible for not just our different electrical systems on our cars, that would be brake lights, kill switches for killing our engine, but also we've got involved with new electrical hardware as well. So we've got a driver dashboard now on our new vehicle for 2021 that displays engine RPM and speed data to our driver, as well as the ability for the driver to select between different modes for a differential to modify for different performance benefits based on the type of event they're racing. We also have a vehicle dynamics sub-team. So their job is to run simulations using a software called Adams Car, which is heavily used in the automotive industry. What that allows us to do is to make design decisions based on simulations that involve the entire vehicle in different scenarios, such as maneuverability, endurance race, that are reflective of the kind of races and different different events that we see in competition. So they really allow us to really improve the level of design that we can do by running these simulations and having that analysis to work with before we go into design, and even having that analysis to ultimately test and validate. Going on, we also have our 2021 vehicle. So we have actually decided, despite COVID and, the challenges such as occupancy limits, the ability to get material, funding, all that sort of thing, we went ahead and made a new vehicle this year for the 2020-2021 season, which is the OR6 Rebirth, which you'll see more pictures of coming up soon. This is our team's first four-wheel drive vehicle. The reason it's a four-wheel drive car, in previous years we've developed two-wheel drive cars. The competition rules have been changed for the Baja SE competition, which is what we compete in, so that for this year, teams that drive four-wheel drive cars will get bonus points, and then starting next year, all vehicles in the Baja SE competitions will be required to be capable of four-wheel drive. So we took that step to have that opportunity to develop, learn, and get that experience in developing a four-wheel drive vehicle ahead of time before it was mandatory, so that we can kind of start to really develop that experience, that knowledge on what it takes to design, manufacture, and ultimately test and race a four-wheel drive vehicle. We've also got a new training program. So this past couple semesters, we developed a new short course semester-long training program. So what that does is it's a design training we'd run within our team, or especially targeted at, for example, first years who have just gotten to Georgia Tech. And it's primarily to help them get involved with the design process that we follow at Off-Road. So it gives them some of the knowledge from, so it kind of combines curriculum from the ME classes at Georgia Tech, so like machine design, ME 2110, and deformable bodies, essentially kind of give students a crash course in design engineering so that they can kind of get that head start into designing components for GT Off-Road, which has been a really successful program. We've got a number of new first years who are already been able to design parts because of the training they got in that program, and many of whom are even taking on leadership positions in design. So that's really been a big part. Finally, we've also been already at some of our competitions, so I'll save the best one for last. So recently, this past couple of weeks, we competed in the Baja SE Arizona competition. So that was the first in-person competition we've been to in 2 years, actually, because of COVID-19. So we had a really good showing there, performing 6 out of 25 teams. Additionally, we also competed in the static events, which are all held virtual. So like Becca mentioned, there's the sales presentation where we competed 30th out of 153, kind of like a Shark Tank event. The big thing I want to highlight is that our team has placed second out of 153 teams in the Baja SE Knowledge Design event. This is the first time, so for starters, it's the first time the team has made the design finals in 18 years. The design event is where we present the design, the testing and validation, and the analysis for our vehicle in front of a group of judges who are typically engineers from different industries. But this is the first time our team has made design finals in 18 years, and placing second, it's amazing. It's an incredible accomplishment, especially for our team. I don't think our team in the last 20 years, in our 20-plus year history, has ever achieved a second-place finish in the design event. And it really speaks to the level of engineering, analysis, and the testing and validation that we put into our vehicle. Especially this year's vehicle has probably at least, over a year's worth of development and design that went into it, which is a lot more than a typical Baja SE vehicle. So that second place finish in the design event really speaks to the level of and the depth of our engineering analysis and the design and testing that went into our vehicle this year with the OR6, especially with the help of our new vehicle dynamics team as well. So, Becca, if you want to go on the next slide. So these are just some of our placing from the recent Baja SE Arizona competition. So we competed in that about a week and a half ago. It was, again, like our first time going to competition in 2 years. It was a really exciting experience where we really got to prove and drive our car and test it on various different events. So there's an acceleration event. You've got the endurance race, which is all the cars are going to be racing on the same track for 4 hours straight. The team that gets the most laps in that amount of time are the teams that will score the highest. Overall, placed 6 out of 25, and then did well in the various other events, such as 5th in the suspension event and endurance, and then 5th in the endurance events as well. But it was a really great opportunity for us to really kind of prove our vehicle, test it out, and really kind of show how our vehicle can perform in different events. So definitely very fun. We're definitely looking forward to Louisville coming up. And just some more pictures of our vehicle and some of the testing and design as well. This vehicle, so for off-road, we develop a new vehicle each year for each competition. We have between usually 1 to 3 competitions we compete in each year. We develop a new vehicle from scratch each year. So we do all the design to the manufacturing as well as the testing and validation, and finally racing at competition. So just some pictures of our driver dashboard in the top left that we developed for this year's vehicle. Some finite element analysis we performed from our design of our suspension, as well as some cool photos from the manufacturing of our chassis and ultimately our testing on our test track in Franklin that we use to collect data on our car and validate our analysis. But yeah, we're looking forward to Louisville. It's our last competition coming up, and we're looking forward to a strong end to our season, especially with that second place finish in the design event. So looking forward to it. The last note is thank you to all of our supporters and our sponsors. We really wouldn't be able to do, ultimately at the end of the day, we're trying to provide this engine development and engineering and kind of help our students get those skills, especially the hands-on skills in design and test and validation, to help them in their future careers in engineering and business. And we wouldn't have the opportunity to do that without the support of all of our sponsors, because they're doing what we would do, developing the off-road vehicles. It takes a lot of funding and support and materials. So we want to thank all of our sponsors for allowing us to do that and giving us the support we need to do so. So with that, I'll open it up to any questions.
Right, we're going to go ahead and move on to GTMS. You guys want to go ahead?
Yeah, definitely. Can everyone hear me?
Yep, you're good. Go for it.
Alrighty. Much like I mentioned earlier, my name is Nick. I'm the president of GT Motorsports. I'm also joined here by one of our newest members, Marvin TM. We're going to be kind of giving you guys a brief overview of what our team is, what we've done this year, and the obstacles we faced. So a little brief introduction about our team. We're Georgia Tech's Formula SAE team. What differentiates us from high tech is we are an internal combustion engine. We design, fabricate, and test our internal combustion class Formula style vehicle. We're fully student-led and driven, which means that everything that we do on the team comes 100% from our members. The way our team is designed and the way our team is kind of put together is we have a structure of a team lead and a chief engineer. And both of those work together to provide the best team and car when we go to our competitions. We're comprised of multiple subsystems, each led by a subsystem lead, and then all of those will have members that follow within each of their subsystems. Our subsystems include our aerodynamics subsystem, electrical, driveline, powertrain, suspension, electrical, business. Pretty much anything that you would see on our car, you're going to have a subsystem for. And we have about 45 total active members across all disciplines and majors, meaning that we accept anybody that's interested in joining our team, especially if they have any sort of interest in becoming a part of the Formula style vehicle class. The way that we train and teach a lot of our new members is by giving them the tools to actually provide hands-on learning experience. And so we almost encourage them to try out each of our subsystems to see which one they actually fit in the best. And then we allow them to then choose which subsystem they'd like to be a part of for the remainder of the semester. And this allows them to kind of cater their experience to what they'd like it to be. And it really provides them an experience which is very fruitful in terms of learning how to utilize many of our machines in the CMA, but also how to design certain aspects of our car. And so, like I said in that last bullet point, is we're giving our members a real-world environment to validate their skills that they've learned in the classroom. So our team, we have 35 years of excellence and a storied history. We're one of the oldest clubs and teams on Georgia Tech's campus. And we've competed internationally as well as domestically, and we've had success throughout much of those 35 years. One of our main competitions is Formula SAE Michigan. It happens annually every single year in Michigan, Brooklyn, Michigan, at the Michigan International Speedway. And it is much like many of the other Formula-style competitions in which there's a business event, which is much like a Shark Tank, where you're giving a pitch and you're kind of solving a certain problem or a prompt that they give you. We also have design validation events, as well as many of your dynamic events, which include an acceleration test, a skid pad, which is kind of like driving around in a figure eight. We also have autocross, as well as an endurance event. And much of those are what determine how you place in the overall competition. And the endurance event is extremely important because it is worth the most amount of points and showcases just how adequate your car is at surviving long sustained speeds for the duration of the entire event. And so this is this year's car. We weren't able to compete last year for the fiscal year 2020, partly due to COVID-19. Many of the restrictions that were placed on us also included much of our competition getting canceled. And so we were only able to compete virtually through many of our static events, which included the business and design event. But we weren't able to actually compete with our car. And so this car was a iteration of what we were supposed to compete with last year. And so this year we have its car 73, and many of the design changes that we've included into this car we're going to be going over, many of which are seen in our aerodynamics package, as well as some of the stuff that we've done with our engine and much of our chassis. So I'm going to go ahead and toss it over to Marvin, and he's going to explain kind of what we've done with the design and how we've exactly moved it into what we have for this year.
All right, thanks, Nick. Yeah, just like Nick said, a lot of the largest components that we've changed for this year are part of the Aero package. So essentially in Aero, everything is designed through iterations in CFD. So this means that we start with like a general idea of what we think will work, and we make a number of design changes until we're happy with the results. This is done for each individual element in isolation, so they're just by themselves in the simulation, and then they're added to the car when we see how it performs, and then this way we can see how it works relative to everything else. So for example, this front wing, each individual element was tested and then put together, and much of the interactions are determined later. So for example, the middle of the front wing, we made so that it direct airflow to work with the under tray, which is a new addition this year. Oh, there we go. And then we try to manufacture a lot of all the parts in the shop, but we also have places like Delta Tech Ops, who generously allow us to use their autoclave which makes parts such as in this picture, this is the floor panel, makes these large parts possible. This is an image of the controls subteam. So this focuses on mainly things the drivers will interact with, and this is the sub-team that I'd initially joined into. The biggest change this year was moving the screen off of the steering wheel and onto the dashboard. Not only does this allow the driver to see the screen a lot more clearly and easily, it also lightens the steering wheel, which lowers complexity there. That's just simply less moving parts. The screen is now mounted stationary and stays there. Also in this image and the previous image, we can see a lot of the carbon composites we do. This is for me as a first year, this was brand new to me, and this was a fantastic experience to get to work with these composites, which is used much in the professional world. This is a closer image of the dashboard with the screen mount. And on the right, we also have a photo of a powertrain and the engine we use.
And so, thank you so much, Marvin. And I'd like to just touch on Marvin's extreme capability and what he's been able to learn throughout the entire year. And we really try to influence much of our first years to follow this same path of really integrating themselves within the team. Just to kind of briefly touch on some of the other additions we did with the car, much of our powertrain, we continue to use a 4-cylinder Honda CBR motorcycle engine as our main source of power. And this year, we really wanted to kind of fine-tune and make the engine as efficient as possible. And we've achieved one of the lowest idling RPMs that we've ever had, which is an extreme accomplishment that we've been able to kind of partake in. And then along with much of our aerodynamic pieces, our side pods drastically reduced in size, which reduced on our overall weight, which was a very good kind of achievement that we were able to accomplish just in overall terms of efficiency and making the car as quick as possible. But next, I'm going to go over our team image and kind of like the goals of what we have going into the future. So much of what our team is focused on is kind of building a future outlook and a future that makes the team as bright as possible. And that starts with kind of developing a lot of our new members into great leaders for the future years. And so by doing this, it's all about promoting the team and creating a professional team image. And one of the things that we started doing this year was trying to outreach into the Georgia Tech community a little bit more, kind of trying to get into the business department of the school as well as the industrial design to increase our overall reach and to be able to find students that can kind of satisfy specific niches that we have on the team that we currently don't have members to follow with. So one of the biggest things is kind of promotional materials. And we started this year with doing an annual video where we showcase our car driving around campus. And so this is a great way to showcase kind of what we've done with our team, as well as the overall accomplishment of the car that we have for the given year. And another thing that's really nice with this is that when we showcase the car on campus by driving it around, it kind of, gives off an aura that definitely Georgia Tech is accomplishing things unlike any other institute or any other university in the country. And by the generosity of the SEC as well as many of our sponsors, we're able to accomplish many of these tasks, and we're always proud to showcase this. And so that kind of, leads me right into thanking all of our generous sponsors. Every single year we have a multitude that are generous in terms of giving us monetary donations as well as in-kind donations. And some even give us just kind of discount donations, which are extremely beneficial to our team in terms of being able to purchase many of the materials that we need. The cars that you saw in the previous slide are our car 73, which is our current iteration. And so we will be testing and competing with that car in Michigan this year. In July 7th is when it has been moved to. So we look forward to kind of showcasing what our car can accomplish as well as what our team can do. And we will always keep you guys updated with how we finish and what we're looking to achieve. But that's pretty much it we have. So thank you so much. Any questions?
All right. And last but certainly not least, RoboJackets, if you guys want to take it away.
Hello, my name is Shashir Pandit Rao. I am the president of RoboJackets, and joining me is Tan.
And I'm Tan. I'm the vice president of RoboJackets.
Yeah, so today we're going to be just going over everything that RoboJackets has been up to this last year. It's definitely been a very interesting year, you know. But regardless of the restrictions at hand, RoboJackets as an organization has strived to make a lot of progress in a multitude of areas. So just a little bit about what RoboJackets is. So our goal, our mission statement really is to promote, educate, and advance the field of robotics as a whole. We do this in a variety of ways. We have multiple education systems. We have a very robust education platform for our members as well as the greater community. We work with our community largely in the greater Atlanta area to promote robotics and STEM education, and we work to advance the field of robotics through drafting, designing, fabricating, and validating multiple robotics platforms in the following distinct areas. We have combat robotics, known as BattleBots, autonomous 6v6 soccer, which we call RoboCup, autonomous off-road navigation, which we call RoboNav, autonomous racing, which we know as RoboRacing, and autonomous sumo robotics, which we know as RoboWrestling. So each of these teams actually operates semi-independently with RoboJackets as the umbrella organization, allowing our teams to allowing our organizations to achieve success in a wide variety of areas. All of our teams collaborate and compete on either a national or international scale, so we got a lot of interaction and collaboration and knowledge transfer within the STEM robotics community within the country and within the world. And on Georgia Tech's campus, we do have a pretty large footprint. We are 240 students strong across 18 majors and over 4 colleges. So we definitely have a very diverse group of individuals who come to us and who we work with to really promote this field. If I were really to just provide, a one-line description about what RoboJackets is, it's that we're a community of project-based learners, right? We appreciate going through the educational process through development, through design, development, fabrication, and validation, and that's something that really speaks to all of our members and speaks to the RoboJackets experience. However, in order to do this, education is a very crucial element. Tan, would you like to talk a little bit about our educational materials?
At RoboJackets, we take a lot of pride in keeping our education open to the entire Georgia Tech student body. For this, we've adapted really well to the virtual environment of the pandemic, and we developed YouTube playlists for each of our disciplines that were publicly available to both Georgia Tech students and beyond. We also set up Microsoft Teams in addition to these and maintained all of these as courses for all of our new members to be able to take and learn alongside each other. We also, in addition to these, provided opportunities to come to the shop and still get some hands-on experience to be able to work with our machinery and get more experience there. And we'll leave it to share for outreach.
As mentioned earlier, one of the major things that we do here in RoboJackets is the STEM outreach element. One of our major events that we host annually is the first FRC kickoff. In this last fiscal year, this was virtual with over 200 attendees, where we were able to host informational sessions with our members as well as high school students to provide them a little bit of context about what robotics is after high school. In addition to this, we've worked with elementary schools in their career fairs to really explain the functionalities of robotics in the real world. One of the other major events that we had this year, all virtual of course, was to help utilize Lego Mindstorms kits, utilize basically Lego kits to help explain neurological concepts for Brain Awareness Day in easy to understand manners for middle school students. It was something that really showed how robotics could be used to lower the barrier of entry for education. Pre and post COVID, we have a lot more outreach events that we do. We work with high school students to provide design reviews, technical design reviews, and we also work with our communities for a lot more for many more presentations, which we plan on doing after this pandemic has subsided. Now I'd like to go into the technical developments of each of our 5 teams that I mentioned earlier. Our first team that we have is BattleBots, which is combat robotics. This is our largest team, which focuses on creating a multitude of different robots of different weight classes that are able to compete and that are able to go through the entire process of conceptualization, design, and development in terms of being able to have a success in the competition arena. One of our major accomplishments this year was designing and developing a translational drift robot. This robot is very, very unique, one of the hardest BattleBots to make because it utilizes the entire body of the robot as a weapon, as opposed to having an external weapon. So the entire body, the entire chassis, everything within it spins at 3,600 RPM, but we're still able to maintain directional motion. This past year has been used to really design and develop and fabricate this robot, and we're currently in the process of validation. One of the other main elements of this program that we've done was ideating, creating, and hosting an in-house competition entirely from scratch. After the COVID-19 pandemic really sort of took away all of the external competitions that we hold, we wanted to ensure that our members had the ability to have a nice, have a very solid competition environment while maintaining COVID safety. So we were able to create small 2-pound robots. About 7 of these robots, so that each of the groups that create these are very small and we're COVID safe, but also provide a very hands-on environment to help new members focus on their technical skill development, accumulating in a competition with about 20 people who came throughout an entire day.
Our autonomous soccer team, meanwhile, has been working to prepare for their competition with 6 versus 6 teams of small-sized robots, and they work towards their goals by building new robots and improving the mechanisms that they currently had to better comply with the new rules of the competition and improve their performance. Specifically, this year they were focusing on their motion control and also improving in different parts of the robot, such as their kicker, to get better distance from which they could kick the ball to the goal. In addition, they will be having a virtual competition in June, which we hope that everyone will tune into.
So this is a very brief video about the control system of RoboCup. This is tracking each of the individual robots as well as the ball itself.
Moving on to our autonomous navigation team. Our autonomous navigation team has been focusing on a new swerve drive-based robot, and also has been trying to rebrand from its previous IGBC focus to a more diverse team that does multiple competitions. On the swerve drive side, they've been making a omnidirectional robot, and you can see a prototype of that robot here. It gives a big advantage to the team in that it allows the robot to drive around the obstacles of the course, regardless of how close it may be. Also, on their new project, they have been building a new rover, and they've started this process by working on some of its components, like the arm for collecting and carrying samples across the terrain.
One of our other teams, which was the autonomous racing team, was very successful in its previous competition, hitting first place overall in their 2019 competition. And this team has been focusing on the development of an entirely new autonomous go-kart platform. This platform is aiming to hit minimum speeds of 20 miles per hour in the next 2 years. So basically, the entire course has to be completed without going below 20 miles per hour. Entirely autonomously and with head-to-head competition. It's very this team is working very, very hard in terms of this development and ensuring that the software stack is robust and able to move through this process. In addition, Robo Racing is working on improving one of their existing robots, which is a 1/6 scale RC car, working to be able to autonomously detect and respond to urban environment flags, such as stop signs, one-way signs, signal lights, etc. On the next slide, we have a brief video about the image recognition platform that we have from the external camera and how that was interpreted by the sensor stack and software stack. All right. And finally, we have our newest team, which was Robo Wrestling, which focuses on autonomous sumo wrestling. This team has spent this last year designing, fabricating, and validating an entirely new robot, which was engineered to have a smaller form factor while still maintaining its current weight and power. This robot, although it's about 8 inches by 12 inches by 8 inches tall, has a magnetized weight of about 300 pounds. So if the magnets are on, you can't really lift it, and it's a very, very strong and powerful platform that our team has really been focused on developing a workflow towards ensuring that their design components are very robust and able to prevent flipping and able to reduce the lever arm as a whole. However, there was a lot of information that was given, but the simple truth is none of what we just mentioned could happen without our sponsors. We have over 20 sponsors who have provided us a lot of support, both in terms of financially and in kind. And we would like to provide our most sincere thank you to everything that our sponsors have provided for us and allowed us to be, and the opportunities they have given for us to be successful over this past year. Our relationship with our sponsors is very symbiotic because it allows them to really have the ability to interact with our members, and it allows a lot of interaction between our members and themselves in terms of providing opportunities for internships and employment for the people of RoboJackets.
All right, and if anyone has any questions for RoboJackets, now would be the time to ask. All right, and before we go, Dr. C, I believe you have some remarks.
Yes, I do. Thank you, Becca. Thank you to all of our presenters today. You did an excellent job. I think you did an excellent job in showing that what you do is so far beyond what's done in the classroom that it just drives home that this is super curricular experience at y'all. And the successes you've all had does credit to yourselves and to the institutes. And I'm just so very proud of your accomplishments. And speaking to our sponsors and other stakeholders, we hope to be doing this again in future years. We thank you for your support. We couldn't do it without you. I think that'll wrap it up for me. Thank you.
All right, thank you, Dr. C. And we will stay on for a little while longer in case anyone has any last lingering questions. And you are always welcome to email info@sccgt.org to reach out to the SCC itself. And if there's any specific teams that you'd like more information about, we can send you their way. But thank you so much for coming out to our event. Have a great day. And again, if you have any other last questions, feel free to put them in the chat. Otherwise, that is the end of this event. Thank you so much for coming out.
Becca, are we going to make a link to this available off of the SCC website and to the teams?
Yes, sir. Because we were recording this session, as soon as BlueJeans finishes processing, this will be available online. So if there are any counterparts of yours that did not make it to the event, we will be providing that link to you in a follow-up email. And then we have a question: is there a feasible way to try multiple teams out if we're having trouble? Absolutely. Something that's really special about the SCC is because we're in one kind of open environment, you are more than welcome to go and speak with and maybe try out any of the teams that you wish. There's really no harsh feelings. In fact, there are quite a few members who have switched teams over the years and have still felt completely comfortable and happy and been able to find an experience that is more tailored to what they were looking for. So it's absolutely possible. Just come on out to the SCC and walk around, see what's up, and talk to any of the teams that you'd like. And again, if you'd like to email any of us, we are all more than happy to have a conversation with you about it. All right, Mr. Wright, I think we can probably stop recording now.